I've heard he's going to be coming soon. He's gone out.
So our toy is called Losing Your Marbles. My name is Taylor. This is Emily and Tom. One of our biggest inspirations came from Wanderset, who we found on Instagram. He did a lot of perpetual motion simulations. A lot of them couldn't be done in real life, but we really loved the idea of motion, so we wanted to implement that. So we came up with our conceptual design. As you can see on our sketches here, we wanted to have the top rotating in the opposite direction of the bottom. This is where we did a lot of our overall dimensioning. We decided how many tracks we wanted to have, how the marbles were going to come out at the bottom, and a couple of other decisions which Tom will talk about in our detailed design.
So internally, it's a planetary gear system. We started with kind of overall dimensions, and then based on the motor speeds and our overall dimensions, we did some calculations in MATLAB to determine the specific gear ratio and number of teeth per gear, which then we went and manufactured and printed.
Next, we did our track design. Our track design was definitely one of the more complicated parts of our project. We originally designed tubes, but you can't 3D print tubes due to the support material that's inside. We also explored laser cutting, but we didn't want to have supports coming off our center shaft. And so we ended up coming up with this idea, which is based off the roller coaster, where it has the supports and then the different track lines that go through it. But unfortunately, as we started manipulating them, most of them broke. And so our solution was to create wire coil tubing, and that is our final result. Here's just showing our motion studies. As you can see, the gears rotate, and we have them rotating in opposite directions to make the project a little harder. And then this video just shows it with the funnel on, so you can see the more complete motion of our project.
So for manufacturing, this part down here is the most complex, so we use the resin printer for that. We mainly use a bunch of laser cutting for flat surfaces like this on our outer border, as well as using the Bloodspot 3D printer and ME building to do some of our lower fidelity parts. For the assembly procedure, we went bottom up. So we started with the base. We started gluing in our transfer bearings, our ball bearings, then we put our shaft in and kind of built up from there with our tracks, and then the final assembly was our electronic package. Going a little bit deeper into our electronics, which we'll show in a bit, they work using these IR brake beam sensors, so when a marble breaks the tripwire of the IR, it lights up a different light set based on if it's the right hole or the wrong hole.
So for our product, we kind of had two different target markets we were looking at. We were looking at kids, because this can be a game. You could have different people dropping marbles at different times and add incentives and stuff in order to, make it fun. And then we also thought of it kind of as an office toy, because a lot of break rooms and stuff have the Newton's cradle and just different things that you can use to kind of take your mind off your workday and just kind of, relax. And
some of our uniqueness comes in our track difficulty, so we kind of made one of them to be the hardest track, which would take the longest, so it requires the most timing. We added the lights to make it a little bit more fun, and it would also be easily integrated into other games, so you could have penalties for if you get it wrong, or like we have incentives for if you get it right. Handy. So we kind of wanted to show you too what our first iteration looked like versus what it looks like today, so we are going to show you this is what it looks like if you get it correct, minus the lights, and if you get it wrong, it'll go down the second hole. As for future improvements, we do want to make interchangeable tracks for it, so that way you could customize it even more. We think it would be a lot of fun to be able to change the tracks around, make it more difficult or easy depending on your audience. We would also love to have different motor speeds, so you can make it faster or slower. The optimization of the overall size, this is obviously a prototype, so it came out a lot larger than we thought it would be. It would be fun to, like Emily said, have it on your desk as a little desk toy. We also wanted to include sounds if you get it right or wrong, and then just a better integration overall of the electrical and mechanical systems. So now I'm going to show you one final product.
as you can see, the main switch is on the bottom, and then the switch for the electrical circuit is on the outside. And then you're supposed to time it so that when you drop it down a track, it either goes in the right hole or the wrong hole. In this case, it'll go down the wrong hole. Is the light sensors on?
That's all.
And then hopefully, let's see if I can get this right. We had some trouble with our gears and constraining it to our center shaft. So we used a bunch of different methods and set screws and adhesion. So that's the problems that you're seeing right now.
Just also from wear and tear of us playing with it a lot, it started to wear through a lot of the press fits we made, and so that's why I said this.
Yeah.
So when it gets wrong.
So that is our toy. Any questions? Questions? Yes.
What do you think would be the most difficult part to miniaturize? Like if you're going to put on the desk, which mechanism would be most difficult to do that with?
So the reason right now that this structure on the bottom is so tall is because the motor is facing vertically. Preferably, we'd want like a worm gear motor, which are more flat and horizontal, so that we can reduce the size of this. So that's really the main factor that it's so large. The gear shouldn't be much of an issue. So I'd say the marble size as well as the motor size. Any other questions? Okay. Thank you so much.